Okay, so now you know what a relation is and what a function is, and they are relating inputs into outputs. So now we're going to look at what a function rule is, and this is an equation that represents the output in terms of the input. So it's very similar to what you're used to seeing. So here's an example of what you're used to seeing, y equals 3x plus 2. If we've decided that this is a function, we can now write this in function notation. Notice we're replacing the y with f of x. Okay, and this is read as f of x. So again, this is the same as y, but when I say it's f of x, I'm talking that it is a function, so all the x's go to one y's. And then you can evaluate or figure out what an output is for an input. So if I input a 1, my output, I can calculate this, and would be 5. So that would be my output. I'm inputting 1, and my output would be 5. The output is the same as the y value or the function value. The x here is the independent variable. Okay, it doesn't depend on anything. It's the input. The dependent variable, which is like the y or the f of x, depends on what the x value is. That's why it's called dependent. You put in an x, and the output depends on what you put in. So that's called the dependent value. So let's use function notation, and let's look at problem 5 to do so. Okay, so in problem 5, they give us the function f of x equals negative 2x plus 5. Again, f of x is very similar to saying y equals negative 2x plus 5. And now we want to figure out the outputs for each of these input values, or figure out the y's for each of the x's. So this is how you would show the notation. We want to find when x is negative 3. So plug negative 3 into the function. That means I'm going to put the negative 3 where the x is. So this means I'm inputting negative 3 into this function. So notice I put negative 3 where the x is in the function. And now compute this right side of the equation. I can do negative 2 times negative 3 and get a positive 6. And then 6 plus 5 is 11. So my answer is 11. Negative 3 is the input and 11 is the output. So there I can write it as a point, or you can write it in function notation like this. F of negative 3. So when I plug negative 3 into the function, my output is 11. Let's try the next input value. My next input value is 0. So I'm going to put the 0 where the x is. And now let's compute the right side only. Negative 2 times 0 is 0. 0 plus 5 is 5. So when I plug 0 in, on the right side I'll get 5. So the function value at 0 is 5. Let's try the last input value of 1/4. So you're going to plug 1/4 where the x value is on the right side. Now let's follow our order of operations. Let's multiply negative 2 times 1/4. As a fraction, it's negative 1/2, or maybe you used a calculator and got negative 0.5. And now add that to 5, and you'll get 4.5 as your value. Or if you kept it in fraction form, you would have gotten 9/2. So we have f of 1/4 equals 9/2, or 4.5, however you wrote it. Now we can use function notation in real life. Let's talk about going to a concert. Maybe you recently saw a concert over the summer. So we can read the problem here. Tickets to a particular concert are available online for $35, but they're going to send you a handling fee because they're going to have to mail you out the tickets of $250. The mailing fee is only a one-time fee, but each ticket is $35. So let's write a function rule for this total cost of concert tickets. So we have a function. Each ticket is $35, and then we have a handling fee of $250. Now the numbers are added to each other, but I'm missing my variable x. X is for each thing. What keeps getting added? We have $35 for each ticket or per ticket, so the x is going to go with the 35. So I have 35 for each ticket, and then the $250 only happens one time because they're only going to charge me a handling fee one time. So there is my equation. Now I can evaluate for 4 tickets. So let's say you and 3 friends are going to the concert. So 4 friends or 4 people all together, how much will the tickets cost? So you're going to put the 4 where the X is, and again, we're only going to add that handling fee one time. So let's compute 35 times 4 will be 140 plus a $2.50 handling fee. So the function value at 4, or the cost for 4 tickets, will be $142.50. Please list any questions you still have.